Hello everyone and welcome to Ground Truth Episode 2. Our guest today is Diego Oppenheimer. Diego has been a pillar of the AI community for many years, starting at Microsoft before founding one of the very first MLOps companies, Algorithmia, in 2014. Algorithmia was acquired by DataRobot in 2021, and Diego stepped up to lead their MLOps strategy. Since stepping down from DataRobot, Diego has somehow managed to make himself even busier, helping to guide the AI Infrastructure Alliance, the MLOps community, and becoming a partner and CEO in residence at Factory. It's quite a journey. Diego, welcome to Ground Truth.
Thank you for having me. Happy to be here.
You've been deeply involved in the AI world for a long time. So I want to start with your take on the current foundation model LLM explosion. Put this in perspective for us. How big of a deal is it?
So I was the reason why I got into ML was really because I thought it was like the most important technology that we were going to go see in our lifetime. And it seems that the thing that was always missing was how is it going to go break into the mainstream of like how everybody could access it. I think the LLMs have really brought that. If you think about it from a user experience perspective, we interact with it with language now. And so everybody is experiencing it. And so we just got that like full, I always hated the word democratization, but it's truly what happened. It's like opened it up to everybody. So I think we're seeing like, what the world is maybe like a lot of us thought could happen with ML, and now it's like everybody's seeing it. And so that's why I think it's such a big movement right now.
Yeah, that's interesting. So do you think the set of people who are going to be interacting and using this technology, I mean, is this going to cause it to grow beyond the traditional sort of ML engineers and data scientists, the people who are actually building with it? And
yeah, so I think if you look at a traditional machine learning workflow, there's kind of like every single part of it was hard. Right? I had to collect data. I had to go figure out how to build a model. I had to go train these models. I had to go monitor and make sure that they were working the proper way. Every single part of that was like really, really hard. And accessing it. And now you have essentially people who are being able to get access to machine learning with just talking to, just putting text into a model and getting a response. If you think about anybody accessing it through API. So the barrier to entry has been lowered. Like now, building these models and maintaining them are like super hard, but like the access point is like really, really opened up.
Yeah, that's amazing. Is there obviously some huge upsides and also some risks that come with opening the technology up more widely, huh?
Yeah, I think people need to I think it comes down to we're very used to people who work in ML understand what a probabilistic workflow is, right? And understand that like, hey, sometimes it's going to behave in this way, sometimes it's going to behave in that way, and we control and monitor and do all these components for that. Telling kind of like the general population that have not experienced probabilistic workflows and who are used to deterministic workflows, right? Which is like, hey, if I do A, I'm always going to get B. If I do C, I'm always going to get D. And they're like, hey, that's not quite how it works. I think that's the part that we now need to educate and kind of get everybody like on board with, because I think that's where the trust factor falls apart, or people are like oh, look, it's just spitting out nonsense. It's like, well, like
sometimes.
Yeah, exactly. By design.
Right. But sometimes it's actually useful nonsense, right?
Exactly.
Very cool. I know you guys at our Factory are at the forefront of all this, and you guys are incubating some really interesting companies. So maybe tell us a little bit about Factory and what you're doing there.
Yeah, so Factory was started by Andy Jackson, Professor Chris Ray. So Chris has been the head of Hazy Research, which is one of the premier kind of like AI labs at Stanford. That lab coined the term foundational model.
Okay.
So they've been working kind of this space for a long time. The idea behind the fund was to essentially go build the companies that should exist and see if we could grab kind of like really like the forefront of research. So it's all based on research. So all of our investment thesis is based on usually academic research and providing that, and putting together great teams and see if they can go do stuff like that. So we look at it as we take high technical risk in terms of what can happen and try to go build out those kind of next generation of AI companies.
Yeah, it's amazing that AI, I mean, it feels like the magic really happens at that intersection of academia and industry, and it's kind of unique in that way.
Yeah, I think like if you look at where you can go with these things, like I think people in research started seeing what these large language models could do, and not just the large language models, but the general like the image models as well. And hey, like this whole generative, the academics were seeing this for a couple of years, right? And they're like saying, hey, these results we're going to still verify them and stuff like that, but this is kind of crazy, like how these things are working. So being at that bleeding edge has all the risks of being at the bleeding edge, but it's also interesting.
Definitely. No, we've seen transfer learning for traditional computer vision tasks being used for quite a long time. So,
yeah.
But it does feel new with like the language models and specifically with generative tasks that they're enabling.
Yeah, I think it's that surprising connectivity of like I can interact with it without like any no cold start problem, which anybody who's worked in ML for any period of time is just like, wait, what? Right? Because like that's what you spend most of your life on, right? It's like, okay, I'm going to train this model, I'm going to get something, I'm going to see some like results, and I'm going to refine on it. And now suddenly it's like, I just did one query and I got the answer, and I'm like, okay, this is like, I think that's where the real magic to me like does. And then as you kind of evolve through, I don't know if you've worked with a lot of them, but like the whole like how you can guide like the context of a language model and start getting responses in that iterative. Like I don't think we've ever, at least from my perspective, haven't really experienced a system that has, even though it's a very temporary memory, right? It's like whatever, 32,000 tokens. Like being able to have that kind of like back in response is kind of amazing.
Yeah, into the last 6 months as these models have exploded, that's been one of the areas where just the amount of growth and the amount of context these models and the memory they have is like just ballooned, which is
somebody described them as like the smartest goldfish you'll ever interact with.
Right. We have our own version of LLMs. We call them lots of little mistakes.
Fair enough.
Our chief scientist John Dickerson coined that once. I have to give him credit. Before Factory, tell us a little bit more about your founder's journey with Algorithmia. You guys were, perhaps arguably the first MLOps company out there.
Yeah, so I have to give. So I think we get coined that because I don't think MLOps was a thing, even though like somebody else bought the trademark and stuff like that. Like, and I think for us it was really like recognizing that inference was a problem. Like that's really what we like kind of like set out to do. So my co-founder Kenny was finishing his PhD. I was at Microsoft, and he calls me and he's like, look, like all these probabilistic like code bases, right? And we call them algorithms. That's why it's called Algorithmia, right? Like it wasn't even like models at the time. It was like all this probabilistic code. Like nobody knows how to package it. Nobody knows how to run it. Nobody knows how to scale it, and it's going to be everywhere.
Yeah.
And I was like, okay, that kind of makes sense. And so like that was really the kind of like insight, is that like nobody was applying software engineering practices to running probabilistic code. And that there was an opportunity to go do that. But there's a company here in New York that was before us, and I'm going to give them credit. It was called Yhat.
Yeah, Austin.
Yeah, it was called Yhat, and
Sure.
And they had two products, and this is where I think like it can actually make sense. I think that they like nailed it. They were way too early, but there's RodeoOps and ScienceOps, and I only found out about this like after they sold. Like, but they had those two, right? And so ScienceOps was their kind of workbench kind of experience, and then RodeoOps was how they put it all together and ran it. Brilliant, right? Like,
Right.
So anyway, I give them credit for like being like the true first.
Yeah, Austin Ogilvy's definitely still around the New York City.
I think he has a compliance startup right now.
That's right. Yeah, they're doing very well. They just rebranded. They were called like, I can't remember the new name, but
So those, I thought they were and after I found out about how they called the two products, I was like, see, they were onto it.
Yeah, absolutely. So I can only imagine. So we started Arthur in 2019, and at that time, in 2019, even the vast majority of customers would go to talk to, were very interested, but also it was very much an education. They were just getting started with AI. So in 2014, I mean, those customer conversations must have been interesting.
Yeah, I mean, so we started with a very developer-focused approach. I mean, we spent, I want to say, from 2014 to almost 2016, like behind the scenes, like kind of build. There was a lot of technology to build. So we spent it kind of. Trying to figure out, we weren't really going to enterprises. We were really just trying to like figure out like what the world looked like from that perspective. But I think anytime you go into greenfield kind of like space, you're going to have this education, call it opportunity, problem, whatever you want to call it. And so, you're kind of going, and I remember going into, I think one of my early conversations might have been actually with you at Cap One.
Back when I was on the buyer side.
And I had like this. It was the same. It was like it was interesting. People like would recognize that this was going to be a problem. It just wasn't a problem that they were having right now because they're still trying to figure out how they could get two data scientists on the payroll to look at the data to maybe build a model. So when I'm going there and being like, you know what, you're going to have all these problems when your model's in production and you're not going to be able to run anything. They're like, sure.
Yeah.
And so that was a little rough for a while.
Definitely. Very cool. It's very different from nowadays. So, fast forwarding to present day, it seems like a lot of the investment that's going in for startups is, companies that are applying LLMs to automating certain now human-based workflows. And when we look at them, some of them, they're varying degrees, but some of them are a very tiny layer on top of OpenAI or another sort of off-the-shelf type foundational model. So, how do you see this playing out over the next 6-12 months? Like, where's the value going to be created?
Yeah.
What companies are going to, become the pillars?
Yeah. So I think one interesting thing is like this wrapper over net new technology is not a new paradigm in terms of like technology adoption. So if you think about kind of like when Mac OS came out, it was a bunch of like wrappers around basic Unix utilities. Mm-hmm. Like that's what you got, right? And if you look at kind of like when the internet came around, there's like a bunch of wrappers against basic like networking utilities. And so I think there's a normal evolution of software that starts with the wrappers around, because it's the low-hanging fruit, and then people start understanding what the technology can do and how they can adopt it, and that's when you start getting the new, like the next wave, right? And so if you look at the first basic apps on the iPhone were like really basic.
Yeah.
I mean, like I joke around with this, but I think like the number one app for like a really long time was just the fart app. Like,
right.
Like that was like on the iPhone, right? Like, and
Has anyone done like LLMs for farts yet? Or
I'm sure they have. So I think like you see that general evolution of like how these technologies, like the low-hanging fruit comes first. People are like, okay, this is what I can exactly adapt to. And then you get the inspired kind of developers and inspired kind of researchers who are like, oh, well, what if we did this? And the new stuff comes out. And so we're just probably in that phase of the technology.
So how does that play out then? Like what's, a year from now or 2 years from now is that, that kind of like thin layer wrapper kind of gives way to the next phase?
Yeah, I think, I have a bias here, and I work with some companies that, I want this to be true as well. So
You're allowed to be biased on this show.
I'm going to be, I'm going to be biased. But so I think one of the problems that you see with these very large language models is the actual size, right? And so if you start thinking about production and how to run them, and like you have cost, latency, like reproducibility across different paradigms. And so I think we're going to have to go to a world where these large language models get distilled into smaller large language models, and that they can be run a lot cheaper, and they can be run on kind of like commercial hardware or whatever commercial hardware looks like. And so in that process, what you do is what I've seen from at least the research side is you can essentially create task-specific large language models that are much smaller and have the same performance. And so I think you're going to start seeing these kind of ensembles and workflows where you start with bigger large language model as a router, and then you coordinate. And so we're probably going to end up in a very similar spot that we are right now, which is like a ton of medium-sized models, just different style.
Interesting. So it almost sounds like you're saying that focus on inferencing time. Is there an opportunity for someone to create a company focused on inferencing time?
I absolutely think so. I think I think it's one of the we aimed. When we started Algorithmia, we really wanted to solve what we thought was like inference at scale globally, kind of like if you think about like what an Akamai for models would look like, right? Because you have to have them globally. We never got there.
Right.
I still think now there's that, if you see how bad the performance is when using the APIs that are available from large language models, the latency is terrible. The models are slow. It's down half the time, and depending on where you are in the world, on top of that. And so I think there's an absolute opportunity to go build out, a true inference service globally that does that. Now I think it's still going to be hard because the people who worry about that kind of stuff are usually pretty advanced. So you'll be in that same space where it's like you're pitching this problem that maybe you'll have later.
Yeah. No, I remember even like 5 years ago, Jensen and the NVIDIA crew were all pushing GPUs for inferencing. But at the time, the predominant inferencing workloads were just tabular structured data models that really weren't that compute intensive, and outside of like a relatively small amount of computer vision models, there wasn't a huge need for it. But it seems like LLMs could change the way that looks, and all of a sudden make all this stuff really relevant. I
mean, we launched, I want to say, it was the end of 2016 or beginning of 2017, where we were doing inference over GPUs. and we launched it, and we needed to do something to like showcase it. And we thought it would be like cool to build, and we built out a website called Colorize It, and so you could turn black and white pictures into color pictures.
Okay.
And it was based off of a neural net from Berkeley, so we got the 3 PhDs from Berkeley to help us out, put the whole thing, deployed it, and we launched it. We thought it'd be the coolest thing ever. It made it to the front page of Reddit, and so Reddit has a lot of traffic, and everybody was uploading pictures to us. And I think like at one point, I remember because it was great because it showcased that our platform scaled.
Yeah.
The problem is we actually hit the maximum amount of GPUs that Amazon was actually willing to give us. I got a call and they're like, no more GPUs for you. And I was like, why? He's like, well, you've saturated this region. And so it was a very intense build.
That's happening right now, actually. A lot of people are having trouble getting GPUs on.
Yeah, I think so. I think they've increased capacity, but I think we were lucky enough, like we were one of the first to use the P2s on Amazon, and then we launched the N4s on Azure, and both times we actually were scaling those out. But yeah, like it was obvious that you were going to want to do inference on GPUs for neural nets, but you're always going to have to do this cost-benefit analysis, which is, okay, what does the workflow look like? What's the SLA I need? Am I willing to pay 4x more? Right? Now you're in the situation where these large language models, if you want to run them, like you're not using a GPU, like it's just going to take forever. I mean, there's some that you can do with CPUs if they're small enough, but like you kind of need it.
No, I think that like some of the LLM makers actually have like clusters of these eight times, NVIDIA's top, it was the A100 cards, and each request is being striped across 8 of like NVIDIA's top GPUs, just so it responds in a semi-performant manner. It's amazing.
Yeah, OpenAI I think got a specific cluster by like Microsoft built an entire data center for them.
Yeah,
I think that was like part of the deal.
It's amazing.
It's a lot of power.
Cool. So with this switch to LLMs, I mean, you've been really passionate for a long time around MLOps. With LLM ops kind of emerging to take on like these LLMs bring on a whole set of new challenges. But you basically have all the traditional challenges along with a bunch of new ones. How do you see sort of the LLM ops ecosystem growing to extend beyond MLOps?
Yeah. So I'll start because I promised Demetrius this from the MLOps group. There's no such thing as LLM ops or FM ops. It's just MLOps.
Oh, so you're anti-LLM ops.
I just think
you heard it here first.
Yeah. There's I'm not anti. I just think there's no need for a new name. I think I get like you are working with different components, but I think it's still operations for machine learning, right? Like you're just running machine learning at scale. I think like the interesting piece is like a lot of the problems are still there, right? And I'm still kind of developing my thesis on it. But when I looked at, I did this similar exercise when I actually started Algorithmia, which was like I looked at what it took to deploy a piece of software, and I said, okay, what are the pieces that break when all this becomes kind of like probabilistic? And that was like, okay, hey, these are the interesting pieces, right? There's the inference piece, there's the training piece, there's the monitoring piece. Like these are all the pieces that like, you needed to go actually do that. In the world now of kind of, for large language models, I think in general, the kind of, the data space and preparing the data and actually getting the right data becomes almost even more important in the sense that you have to like prepare these like surgical data sets to like be able to influence kind of either the training or the fine tuning. So that becomes really interesting. I think the training gets blown up, right? It's like a complete different style of training models. It's you need different hardware. You need like, so the whole how we're going to go train
For you
models.
talking about like the fine tuning or even the core?
No, just the training. Even the foundational models. Like it's a just different style. I don't think the current commercial workbenches adopt that well. I mean, people use SageMaker and other tools, but like it's not. I think Ray is becoming like a big thing that people are using for that. I think
it's kind of like this continual training process, right? It never really ends. It's just like constantly evolving.
Exactly. Experimentation becomes really interesting from a component perspective because now you have, like that still matters, especially on the, but also on the kind of like if you think about how you do in the fine tuning process, kind of like how you run these experiments, how you kind of like manage them. Inference is, anything doing inference today pretty much doesn't work because you don't have commercial hardware on the other side that you can do it. So if you're trying to manage memory and GPUs, if you're trying to manage like everything breaks. So that needs to be refigured out. And then, and we've talked about this before. Like I think the monitoring has its boom again, even bigger boom, right, around this because people are really trying to understand, what the outputs look like. When I think there's certain concepts that kind of maybe get lost, but like how to understand like what inputs are working with what outputs and what's happening and like how far off from these things and what do you actually get to ground truth with. Like these are all things that like continue to matter. So I think the space is still very exciting to me. I think it's again, to me, like there won't be a difference between machine learning and software in the next, over the next couple of years. I don't know what the prediction is, like 5 years, call it, right?
Yeah.
Like because it's going to be implied that every single piece of software has some level of ML involved in it, and so this is just going to be like, maybe at that point it's not even MLOps, right? It's just DevOps,
right?
And just the two merge together.
Yeah, no, but it's just the step change from, as you were saying earlier, deterministic to probabilistic and what that means. But all software at some
exactly. All software becomes probabilistic at some point.
Yeah, absolutely. And there's a step change in sort of the tasks that it can accomplish, which is amazing to see. Tell me a little bit, over the last, I feel like in our 4-year journey, which is relatively recent, but we've seen some of our customers go from having just a handful of models in production to in some cases hundreds of models in production, and like drawing that line forward, like we firmly believe there's going to be thousands and tens of thousands of models in production, especially at these large enterprises doing all sorts of tasks. And so, what about like the current kind of MLOps and sort of workflows breaks? You're talking about what LLMs break. Like what do you think that kind of scale breaks?
Yeah, I think the general management, right? So like again, like if you think about the big components in software development for managing very large software projects, right? Like your source code management systems, your Jira ticketing system, like the whole thing is really around, partially it's about management, partially it's about governance, right? Of that code base, where it is, what state it is, how we're doing, what's where and when, right? So you're not like losing like things. I think that same philosophy needs to be applied. I think it's fairly normal to, or should be fairly normal to assume that most companies will be especially large companies, thousands of models and different parts of software. It's like, okay, well, how do you manage all of that, right? How do you know where it's running? How do you know that they're still working? Like who called what, when, with what data and why? Like that needs to be able to answer inside that space. And again, like we do this today in just a different side of our stack, right? Like people understand where their code bases are and what components are and what they're building and how to track all of these things. And I think that's just, once you have those workflows and kind of philosophies in place, managing one versus thousands of models, shouldn't be that big of a stretch.
Mm-hmm. So one last question on this topic. What still frustrates you about the space? Like, you obviously with Factory, I'm sure you must spend a lot of time thinking about this, like where the gaps are and what can the community do to address some of those?
Yeah, I mean, I still think like at the core inference isn't solved, right? Mm-hmm. I'm really I still think if I think about how you're going to run, LLMs on every single corner of Earth with a low latency. So I think right now I think the state of the art on GPT 3.5, inference was like 29 milliseconds. And so if just 29 milliseconds to do one inference, and I have to stack these things, I have to build a workflow. Like I have like a whole bunch of use cases that just don't work, right? So if you think about in financial services, I know you guys work with a lot with it. Like, you have like the sub 20 millisecond use cases, you have the 20 to 90 millisecond use cases, you have the 90 plus, right? And so how are you going to fit these things into those workflows? So we're going to have to come up either with ways of either you can compressing the models, making them smaller, running them in a bunch of different places, but also it's just, there's physics involved, right? Like if I'm in Australia, I need to be able to call a model in Australia. If I'm in Vietnam, I want to be able to call a model in Vietnam. That sounds great. So yeah, sure, I can replicate it. But now I'm fine-tuning models, right? And you're interacting with it and you're fine-tuning and I am. So if we're corporate and we want to grab the fine-tuned knowledge as a group versus individuals, how do I replicate that across the entire globe in a very easy way and then start calling it? So I think there's a whole level of challenges that when Kenny and I kind of set out to say, hey, this is, you start dreaming about what you could solve that are completely unsolved, still. And that to me is, I think still where there's some work to do.
Yeah, absolutely. With foundation models, a lot of the buzz the last 6 months has been around language models, but we've seen for traditional computer vision tasks a lot of going back years, people using transfer learning and other techniques to solve this. Do you think we'll see the same thing come to structured data at some point, or do you think this is really just in the domain of unstructured data? How do you see that playing out?
Yeah, so you start seeing, like I guess just kind of in that road. Like there's a couple papers coming out for time series, right? Mm-hmm. And using kind of these like models for time series, and so I think you'll start seeing that kind of like movement. The question then becomes, there's this kind of common joke that like with structured data, it's like, when does an XGBoost just beat everything, right? Like what can you solve with those kind of like like you can solve most of these problems already, yeah. and so the question is, what are you going to get other than trying to like fit something that probably like, so I think there is going to be a bunch of advancement in it, and as I said, like the time series space is probably the most interesting.
I mean, do you think there'll be a general purpose time series thing where you can give it a prompt for whatever task you're doing?
There was a paper, I have to go look it up, but like there's a paper recently that came out on literally that.
Cool.
Which was like kind of like how do you kind of like build out, and I'm not really sure if what it's looking at is the shape of the time series and trying to kind of like like reference it, but like it was really interesting. So I think we're going to get to there in that space.
Very cool. I think we have time for maybe one or two questions from the audience. I know, Victoria, do we have some questions?
Yes, we have a couple questions. All right. So this question, you've talked a little bit about kind of what, early days of things and what might be coming. This question is from Sam Zeitlin, who asks, what do you think about clearinghouses of shared models like Hugging Face? At what point can we stop creating so many similar models and just reuse existing ones that are close enough?
Yeah, I mean, I think that's a great question. The idea that you should be able to kind of like use these models that exist, especially this open source movement where you can kind of start from the basis of these and then kind of like go, start from that point and go forward, is really how I think the whole large language model like world is going to evolve, right? So you saw in the last, it feels like it's been forever, but it's like the last 3 weeks, right? Like, like four or five different places.
That was like 2 generations.
Yeah, right. Like there's these 2 leaps, and it's only 2 weeks. They're launching all these like, you could start with like Stanford put out Alpaca, which you can like run on your laptop, and you can like start training your own model. So like this idea of personalized large language models, which start from a basis of open source, is really interesting. And at the core of that, Hugging Face is really kind of like showcasing, storing, deploying those open source models and making them available. So that as a starting point, it seems like almost like already reality that's going to be kind of the general thing. You can customize your own model to yourself, run it privately, et cetera.
It's been amazing. We've seen over the years a number of vendors going back to like the Hadoop providers and people like that try to create these marketplaces for models, and it's never really caught on. But it feels like with this new generation of models, like they are really like pretty generalizable, pretty amazing.
Yeah, this one's not dissimilar. This one is for you, Diego, from Will Skirdick. He's asking, what do you make of the head training wrappers for LLMs as a business model, basically creating domain experts for customers? Is this a short-lived trend?
Can you repeat it? Sorry.
Sure. What do you make of the head training wrappers for LLMs as a business model, basically creating domain experts for customers? Is this a short-lived trend?
I don't know if it's a short-lived trend in the sense that like, I think, so there's kind of 2 areas. One, which I guess I call it like AI UX, which is the experience of delivering AI into a workflow. And a lot of these wrappers are doing that, right? They're delivering an experience and building UXs and building, not UXs in the pixel like form, but the actual kind of like how you get the user to experience this workflow is a hard problem. And you can create, in my opinion, truly kind of like things that stick, right? The question is like, okay, how easy it is to disrupt, right? I think like, if you look at, Microsoft's about to launch, LLMs into literally every single app, right? And so, okay, well, what are you providing beyond that? Are you providing beyond that experience? Are you, what's the workflow that you're tying into? Because that's going to be a disruptive. I'm not saying it's going to be the best. I'm just saying it's going to be there, right? Because like Word is on your laptop, so you're going to open it. It's just going to be there. And so I think you'll have to be really clever about those things, but I think there is space for creating very specific experiences for for different kinds of users.
Great, thanks. Cool. Thanks for those questions, audience. We're close to the end of time here, but there's a couple more things I wanted to ask you about. One was this letter that came out last week from Elon Musk and Emad and a bunch of the AI people saying we should pause training on giant models and for the next 6 months while we kind of figure out what they mean. I'm curious just to, your thoughts on that and the idea of like AI safety with these models and how we should be thinking about it in general.
Yeah, so I think, the concept behind this like pause is people are like, hey, we don't really know what's going to happen with it. But I also think if you look at the entire history of humanity, like when has like, hey, stop ever worked in technology, right? Like it's just like, it feels a little bit like a fool's errand here. It also coming from a lot of people who are like at the forefront and like they're saying, oh, we're at the forefront, therefore you should all stop.
Yeah.
It's like, that feels a little disingenuous.
Don't catch up to us.
Right? And so I think there's, a lot of like AI safety people and engineers that said, hey, like there's an unknown and valid, right? And an unknown is an unknown, and the unknown could be horrible. I just don't see how this implementation of stopping or saying take a pause, like, other countries aren't going to stop.
Yeah.
Right? Other governments aren't going to stop. There's no evidence in the history of humanity that's being like stop advancing has ever worked out in our favor. And so I just don't get it, to be honest. Like it seems kind of.
Yeah. What do you think? I mean, this is obviously a form of kind of, industry self-policing, albeit a very organic one. I'm curious your thoughts, like longer term. Is this something where, it needs to be more regulated, or are the regulators even going to be able to move anywhere near fast enough to make a difference here?
So let's look at that. Like I think like one of the main arguments is misinformation, right? And so they're like, oh, look how easy it is to generate misinformation. It's like, sure, misinformation is easy to generate, but like the distribution channels existed before this. Mm-hmm. Right? I mean, like, so are we going to go shut down the distribution channels? Because I can generate all the nonsense I want, but if I can't distribute it.
Yeah.
Right? And so I think like that's like, I'm not against regulation as long as like it makes sense. This is just fear mongering, it feels like, in terms of like we need to have something concrete that actually might work and say, okay, well, here's how we would go study it, here's how we go check it. But like half the, OpenAI doesn't publish any of their, now they've decided any of their work, any of their like, they're just like, it's closed now, right? And people have a problem with that. Okay, that's, if you really are super concerned about, the safety of the world and stuff like that, just make it open, right? There's a ton of researchers who want to go, kind of like, touch on it and break, kind of see what it does and want to be able to kind of like attest, hey, this should be a risk. Like that's how we've done in all technology. You have an academic, world that will always be curious and pushing the envelope to try to test those boundaries. So I think we need a regulation, obviously, once we actually know what to regulate.
Yeah.
But
very cool. All right, one last question for the road, and then we'll let Diego get on his way. But if you could conjure up a startup, and with Factory maybe you can, to automate any part of your life using LLMs, and we're guaranteed it would actually work, what would you like to see? It can be personal or professional.
Yeah, no. So it's interesting. So like I've been using pretty much as LLMs in like a bunch of my workflows, like on a day-to-day basis. And the best way I've described it is like I feel like I'm like Neo in the Matrix. It's just made me 10 times more productive. Like everything I'm just faster at because I can, I was joking, I was trying to get some of these models running on my computer and I'm not like particularly good with like PyTorch, and it was just debugging PyTorch for me. And like, that was amazing. Like I was like, I would have never done this on my own. I think like I'm very bad at time management in terms of like my calendar and overcommitting and like planning, and I've traveled to cities that I was not supposed to be at, and I've booked hotels for the wrong days. And so like if I could just get that done for me, like I would personally be in a much better spot.
That seems doable. So there's got to be some startup out there working on that, right? Somewhere. If you talk to Diego, if you are.
Yeah. You're lucky I made it here today on time.
Awesome. Well, hey Diego, thank you very much for coming out. Really appreciate it. All right. Thanks for joining us on Ground Truth, Episode 2.